All right. As the name of the assignment implied, we are going to be doing some more practice with the power rule for derivatives. And this whole week, we are going to be just cranking out new rules for derivatives, calculating derivatives. These are a really important foundation for everything we're going to do in this whole unit. Using derivatives, you have to know how to calculate them. So this week's going to be a lot of practice. Some of it will take you a while. There's going to be a lot of different rules, and these rules will kind of build up as we go, but we're really going to take the next week or two and just nail derivatives. Just practice. So these are good foundations so we can actually use them for useful things. So we did talk about the power rule last week, but I feel like we probably need a little bit more practice on that because it is such a vital part of what we're going to be doing. So in this assignment, we're just going to be a little more practice on that, and also doing the power rule with our roots. So those are the more challenging ones, which are some review of Algebra 2 stuff using our rules for exponents. So definitely good to practice those some more. The first section here, hopefully these are starting to get pretty simple for you. The power rule says that you bring this power down. If there's a number in front, we're going to multiply it, and then we subtract 1 from the exponent. So f prime of x for this first one, we're going to do 4 times negative 4. And I'll go ahead and write this first one out, but we're not going to need to do that long term. So 4 times negative 4, and then we subtract 1, so it's really like 4 minus 1 for the exponent, minus 2 times, bring the 3 down in front, x to the 3 minus 1, plus 2 times, bring the 2 down in front, x to the 2 minus 1. So this becomes negative 16x to the third minus 6x squared plus 4x. You obviously don't have to write out that middle step. The better you get at this, it will just become second nature. You'll just do that in your head and be on your way. So for this first section, should be pretty much a review. Hopefully these are easy for you. You have 8 of these questions. I'll just do one other one here. So for this one, we're going to bring the 5 down in front. And also notice the different notation on this one, dy dx. Remember that's another notation for derivative. It means the same thing. Sometimes you'll see dy dx. It could just be d over dx. It could be f prime of x. It could be y prime. All of those mean derivative. So in this case, dy dx, that's what it means. So dy dx then is going to be negative 5, bring it in front, x to the 4th, plus 9 times 2 is 18, x to the 1st, minus, well, if it's 2x, we just drop the x off because it comes x to the 0 power, and it just becomes minus 2. And then we leave off the 8 completely because the derivative of any constant is just 0, which means we don't write anything for that. We'll punch this in. And that is all there is to it for power rule derivatives for a simple polynomial. So let's get up a little bit more challenging here. For this next one, we're supposed to find dy dx. As I've said in the last video, when we do this, we want it in radical form, meaning we don't want rational exponents like 1/2 power or a negative either, so we're not allowed to use any negative exponents because, well, it's just not the right way to do it, and on the AP test, they're not going to have answers written in that way. Unless it were be given to you as a fractional exponent, you could write the answer in a fraction exponent, but generally it's going to be given as a root, so they expect your answer to be written as a root with no negative exponents. So to find dy dx, the first thing that we're going to want to do in all of these is just rewrite it in a better way. You're probably not going to be able to do this without first writing the exponent as a fraction. So we transfer the exponent to a fraction, we do our derivative, and then we transfer the exponent back to a root form. So what we're going to do first is just rewrite this. I'm going to write it as 5, 6. So I'm just going to pull the numbers out in front. X to the 1/2 power, because the square root of x is really, it's the second root of x to the first, essentially what we have, because we just don't write the 2 out there, and we don't write the 1 there either. But remember, the top is the power, and in this case would be the inside, and then the root becomes the bottom. So the top is the power, and the bottom is the root. That's how I remember it. So the power becomes the top of our fraction, and then the root index becomes the bottom of our fraction. So that's where the 1/2 comes from. So now that we have it written that way, we can go ahead and do dy dx. We're going to be multiplying 1/2 times 5/6. So it's 5/6 times 1/2. And then this becomes x to the 1/2 minus 1, right, if we were to write out each step. That then becomes, well, we got 5/12. X to the 1/2 minus 1 would be 1/2 minus 2/2, right? So that would be negative 1/2. So this would be an answer for the derivative. However, we cannot use fraction or negative exponents. Right. First thing that I would do is always get rid of the negative exponents. So this becomes 5, and then negative means it goes to the bottom of the fraction. So 5/12 x to the 1/2. I would do that step first. So we just got rid of the negative, take it to the bottom of the fraction. And then we need to transfer that 1/2 to a root, and that would be the square root. So it's 5/12 square root of x. And that is how we need to type it in to our answer here. Make sure you write it in that form. You'd hate to do the problem and then not get credit for it because you didn't type it in correctly. These are challenging, but they are basically just using Algebra 2 skills, and I guess you could say some pre-calculus as well. So it's, if you're not, brushed up on those, we don't have really time to go over all those skills, but you'll, get practice on those the more you do these. So with our next one, we're supposed to find f prime of x. But first of all, we want to rewrite our function f of x using fraction exponents. So I'm going to pull that fraction out in front, first of all, negative 4/3. And then this square root of x cubed. Remember, there's an invisible 2 out here. And the top is the power. So the power becomes the top of our fraction. And then the root index becomes the bottom. So this is x to the 3/2 power. So now we've got it in that form, we can go ahead and find the derivative, f prime of x. We're going to do negative 4/3 times 3/2, because we bring the power down in front, multiply it, times x to the 3/2 minus 1, so I'll just say 2/2. That's the same thing as 1. So this becomes negative 12/6 x to the 3/2 minus 2/2 would be 1/2. Right. Well, negative 12/6 is actually just negative 2. And then x to the 1/2, there's no negative, so that's great. We don't have to worry about that. But we do need to turn that back into root form. The 1/2 power is just the square root of x. So this one would just be negative 2 square root x as our solution. Let's go ahead and do a couple more. All right, so for this one, first we want to rewrite it as a fractional exponent. Bring the fraction out in front there, 2/3. And then this is the 6th root of x. So 6th root, that's x to the first power, right, if there's nothing there. So remember, power is the top, the root is the bottom. So that would be x to the 1/6 power. Then we can do the derivative. So it becomes 2/3 times 1/6. X to the 1/6 minus 1. Well, 1 is the same thing as 6/6. So that would become 2/18. Multiply x to the negative 5/6 power. We can reduce that fraction to 1/9. And since this is a negative exponent, it will go to the bottom, so it would be x to the 5/6. And then now lastly, we can write that fraction as a root. That would become 1/9. The top is the power, so it's going to stay x to the 5th, and it's the 6th root. The 6th root of x to the 5th. Top is the power, bottom is the root. Say that over and over in your head. Top is the power, bottom is the root. So this is going to be the, I think we have to do 6 and then n, oh, never mind. The nth root, the 6th root of x to the 5th. All right, so hopefully you're starting to get the hang of that. This next one, we won't do the whole thing, but just how you're going to rewrite this would be 3/2, and then top is the power, so that would be x to the 4th, bottom is the root, so it would be 4/5 power.